All right, page 172 in your textbooks. You did numbers 1 through 8 and 12 through 15 for homework. Have that at the ready. Also have your compass, your protractor ready to go. We'll get to those in just a moment. First, I want to review some things with you. And we talked quite a bit about triangles. I know yesterday we started looking at circles, but before that, the discussion for the last several class days, including before Thanksgiving, had been triangles. And we said a triangle has how many sides, class?
3.
How many vertices?
3.
How many angles? 3. Now, with these 3 angles, what will always be true about the 3 angles of any triangle, Kirsten?
They'll all add up to 180.
They'll always add up to 180 degrees. And because that's true, with these angles in a triangle, there are only certain ways you can have them. For instance, you can only have how many obtuse angles in a triangle? Jalen? 1. And that means the other 2 angles would have to be acute. So you could have obtuse with a pair of acute angles. What's another way you could have your angles in a triangle?
1 right angle and 2 acute angles.
You could have a right angle and a couple of acute. What's the only other possible option, Elaine?
No, can ask me. Let's see.
You could have obtuse and 2 acute. You could have right and 2 acute, or
No, not reflex. Straight. Wait, no, not straight.
Sam?
Can you have acutes?
How many?
Oh.
You could have all 3 angles as acute angles. There we go. Now, if all 3 angles are acute, back to Elaine for redemption, what do we call the triangle?
It's all the same, so I don't know.
Bryson?
Oh.
I don't know if you're gonna pick me.
You're the one giving her a look of how could you possibly
I thought
forget
she was,
it?
it's a lane, so I thought she was gonna get it.
Oh, that's a compliment. Okay. A little backhanded, but a compliment.
Acute triangle.
An acute triangle. If all the angles are acute, Bryson, it's an acute triangle. Okay, Bryson, what if one of the angles is obtuse and the other 2 are acute? Luciana's giving you a face. Okay, Luciana, you got to bail him out now. Obtuse triangle. If you got an obtuse and a couple of acute, it's an obtuse triangle. Okay, what if you got a right angle and a couple of acute angles, Bryson? You have a right angle and 2 acute. A right triangle. You got a right and then 2 acute angles. It's a right triangle. What if it's not just an acute triangle? What if all 3 of the angles are exactly 60 degrees? Now we have a triangle with not just 3 acute angles, but 3 equal angles. We would refer to that then as an equiangular triangle. Good, an equiangular triangle. We talked about sides and said that it is possible for all 3 sides of a triangle to be equal. If all 3 sides are equal, Corey, we have
Equilateral.
equilateral triangle. Now, I said this, for a triangle, if it's equilateral, class, it's gonna be equiangular. If it's equiangular, it's going to be equilateral, right? The 2 go hand in hand for triangles, that's true. If all 3 sides are equilateral. What if at least 2 of the sides are equal? Could mean 3 are equal, but if at least 2 are equal, then we have a name for it. Isosceles triangle. What if none of the sides are equal? Sam? Scalene triangle, very good. And so we talked about all those different kinds of triangles. We said that if you know all 3 sides of a triangle, or suppose you're told, hey, I've got a triangle with a side that is 3 inches, I've got another side that is 4 inches, and I've got another side that's 12 inches. Something about that should just be like, yeah, that ain't right. What is not right about what I just said? Jalen? Michael?
About that 3 and 4 inches don't add up more than 12.
Yeah, the 3 and the 4, they don't add up to more than 12, right? I mean, how can a 3 and a 4 possibly reach 12, right? Okay, you know what I'm talking about. You drop a pencil on the floor and it's just out of your reach, and you go try with your arm and it can't reach, try with your leg. It's like, can a 3 and a 4 reach to opposite ends of a 12? No! These 2 would have to be. Now, what would be a number that I could put right here, for instance, Michael?
You could put 6.
I could put a 6. Or class, I could put a
5.
5. Or I cannot put a 7. Because if they just reached a 7, that'd be a flat line. It wouldn't be a triangle. I could reach to 5. 4.
3.
3.
2.
2.
1.
1.
0? No.
If there's 0, it's not a triangle anymore.
0.5.
It could be anything up to like 6.99 or anything down to 0.001. But it's gotta be more than 0, of course. But anything as long as it's less than 7, you could actually have a triangle. With the angles, if I'm like, well, I know that this angle is 70 degrees and this angle is 60 degrees and this angle is 80 degrees. Should be like, wait a second. That ain't right. What's not right about it, Bryson?
Because all of them add up is more than 180.
Yeah, they add up to more than one. Oh, I'm sorry. I didn't mean to make them add up to more than 180. Let's make this a 40-degree angle. Now is it better, class?
No.
Why not?
Because it's less than 180.
It's less than 180. Gee, you're picky. You don't want it to be more than 180. You don't want it to be less than, no, class. It has to add up to
180.
exactly 180. Well, fine then. I'll just tell you 2 of the angles. Is that okay, class?
No.
Yes.
Yeah, it's okay because we may not know what this angle up here is, but at least the 2 of them together are less than 180, which leaves room for there to be a third angle. But if I said that this angle was 100 degrees and this angle was 90 degrees, is that okay?
No.
No. Well, okay, what if I said it was 80? Now is it okay? That's up to 180, right?
No.
Because there's still no degrees left for the... Okay. 79 degrees. Now are we okay?
Yeah.
Technically, I mean, it's obviously not drawn to scale because this should look like an obtuse angle. How big would that angle be up here?
1
It'd be 1 degree. It'd be very, very tiny. But it is at least possible. Let's take a look at the homework now. Talking about circles. And we said a circle is just a closed curve, but it's a special closed curve. It has one clear point in the middle. What do we call the point in the middle of the circle, class?
Center.
The center. And what must be true about every single point on the circle with relation to the center point? It's what makes a circle a circle. Jalen, for some redemption.
It has to be like half the diameter.
You're kind of hinting at it, Ben.
Radius.
Well, if we were to draw from a point to the center, we would call it a radius, which is half the diameter. But what has to be true about every single point here for it to be a circle? Elaine?
It has to be the same length from the end to the circle.
There we go. It's got to be the exact same distance, right? If this point is further away than, say, this point. If this point's closer and this point's further. Let's say this is 5 inches and this is 6 inches. Well, then it's not a circle. Right? Because every point has to be the exact same distance away from that center point all the way around. Now, how would I name a circle? How do you name a circle? Griffin?
With a letter in the
Kirsten?
From the center.
The name of the center point, right? So if we look at the homework, what is the name of our circle? That blue circle there, class?
P.
It's circle P. Number 1 then asks what point is the center of the circle? Well, obviously, class, that must be point
P.
P is the center. The next thing it asks about is a chord. Well, what is a chord, Luciana?
It's a line from one endpoint of a circle to another endpoint.
It's a line that starts on the circle and ends on the circle. So the end points of the line are somewhere on the circle. I see 2 different chords in this circle. Give me one of them, Bryson.
Q and S. Or QS.
QS, there we go. So QS, we just put a little line segment over that. Line segment QS. What's the other chord in the picture? Go 2 for 2?
QR.
QR, not the code. All right, and there's our 2 chords in the circle. Now, one of the chords is special, though. Chord QS is special, class, because it goes right through the center, which means, Griffin, QS is not just a chord, though it is a chord. It has a special name.
diameter.
It's a diameter. And when it asked on number 4, name a diameter of the circle, there was only one you could name, and that was QS. I mean, if you called it SQ, it's the same thing. But QS for number 4 is the diameter. Number 3 asks about a radius of a circle. A radius doesn't start and stop on the circle. A radius starts where, Corey?
At the center.
At the center, and it goes out to some point on the circle. So I see 1, 2, 3, 4 different radii. Give me one of them, Corey.
QP.
QP. Give me another one, Jalen. He said QP is one radius, but there's a bunch of other radii.
PT.
PT would be another one. Give me another there, Sam. PS, and then one last one there, Kirsten.
PT.
We already said PT.
PR.
PR is the last one. Any of those would have worked for number 3. Number 5 says, what fractional part of a diameter is the radius, Griffin?
RP. Well,
Well, RP is a radius, but what fractional part of a diameter is a radius?
Half.
It's half, right? A diameter, or a radius rather, is half a diameter. It asks for number 6, why isn't QR a diameter, Michael?
QR isn't a diameter because because it doesn't pass through the center.
It doesn't pass through the center of the circle, so it may be a chord, but it's not necessarily a diameter. Number 7, it uses the term arc. What is an arc, Elaine?
Like a section of the circle.
Yeah, it's just a part of the circle, a section of the circle. It's a curvy part. So on this circle, there's a whole bunch of different arcs. Give me one of the arcs you see, Elaine.
QT.
Okay, QT is an arc of the circle. Give me another arc that you see, Bryson.
TS.
TS. Give me another arc that you see, Jalen.
QR.
QR. Give me another arc that you see, Ben.
TQ.
Okay, that's the same thing as QT, but yes, or ST. For that matter, would RT be an arc class? Yes. It just happens to pass through S, but RT is an arc. What about QS? Would QS be an arc class?
No.
Yes, but QS, that arc, either QRS or QTS, those two arcs are special. They're not just a part of the circle, they're how much of the circle, class? Half. So we would refer to those arcs, class, as being semicircles. Now, when I just write, for instance, QS, well, if I just write this, we're probably assuming we mean the line segment, which would be the diameter. How would I indicate I mean the semicircle, the arc QS? What do I have to do, Bryson?
You put like a curvy line.
There we go. Put a curvy line, an arc marking up above it. So if we talk about arc QT, we put a little curve over it. If we talk about arc QR, as opposed to the chord QR, we put a little arc over it. That way we can tell which one we're talking about. Questions on the different parts of circles. Dropping down here, number 8, we said a radius is half a diameter. Class, that means a diameter is how much of a radius? Double, twice as much, right? So on number 8, they give you a circle A. They don't actually draw it. They just tell you there is a circle named A. And they tell you the radius is 12 yards. What is the diameter of that same circle, Luciana? 24 yards. For circle B, they say a diameter is 14 feet. Ben, what's the radius?
9.
We're on 8B.
Oh, 7.
7 feet. Make sure we use the unit as well. Circle C, if the radius is 4.5 inches, Ben, what's the diameter?
9 inches.
9 inches. And on 8D, circle D, if the diameter is 5 meters, what's the radius, Corey?
2.5 meters.
2.5 meters, or 2.5 meters. How many could go on the chart, therefore, number 8? Dropping down to number 12 through 15, they wanted you to get your protractor out and go up to that circle, the blue circle, circle P, and measure each of the angles that's at the middle of the circle. We're going to talk about these central angles a little bit more today, but they wanted you to start by measuring angle QPR. So as you look at the circle, again, I'm going to go and draw a similar looking thing here. We had P, of course, is the center. We had QS, the diameter. We had this radius from P to R. We had this chord, and then we had down here from P to T. You were measuring angle QPR, this obtuse angle here. How big was the obtuse angle, QPR, when you measured it? Bryson?
130 degrees.
It was 130 degrees. Excellent. How about angle RPS? Angle R, I'm going to go and write 130 degrees in here, by the way. How about angle RPS? That was this angle right here. How big was that angle, Griffin?
55 degrees.
You're close. You're a little off. He's actually correct, class. It's exactly 130 here. Question, class. What's got to be true about these two angles? They've got to be supplementary, right? So if 130 is here, Griffin, it actually would have to be 50. Now, again, we're up against the binding of the book, so it's very possible when you measured it came out looking like 55. But if it were 55, then that would have to look like 125, wouldn't it? What about angle SPT? Class, how big does angle SPT appear to be?
90.
It looks like a right angle, and in fact it is a 90-degree angle, which means this angle, QPT, would also then have to be, class, 90 degrees, because what has to be true of these two angles? They also must be supplementary with each other as well. Questions on those angles? Any questions on the homework? Flip back then, if you would please, to page... Actually, just keep your book open here, better yet. If you would, set your book on the floor beside your desk. Set your book on the floor beside your desk. Have it a blank sheet of paper. And we're going to do a little bit of drawing here with your compass. Now, this is not going to show up too well on video, so I apologize in advance, but I did already record a tutorial for you, for those watching on YouTube, so check that out. I'm going to show the rest of you here. I'm going to kind of position myself at different points so you can see different things, and I'm going to steal a compass from someone here in just a moment. As we draw circles, there's a right way and a wrong way to do it. There's a best way, I should say, and then there's the way that leads to disaster, and we don't like disasters. One of the things, though, as we draw circles is we need to be able to measure the circle to the proper amount. Now, some of your compasses, I steal this from you for just a moment, have a little scale on them. How many of you, as you look at your compass, it has a little scale on there that tells you how big the radius is? My caution would be this: unless the... Oh, there's you have a retractable tip.
Yeah.
That's cool. Okay. Unless the pencil tip and the pointy tip of the compass are perfectly aligned, that scale is not accurate. Jalen's is really close, but they're not quite perfectly aligned. So if she goes off this scale, she's not going to be perfectly accurate. My advice, and some of you, how many do not have a scale on your compass? Yours is simply the two legs that come out. Okay, many of you don't even have a scale on your compass. When we measure, for instance, look at number 9 in your textbook. You look over there on the floor. It tells you they want a circle that has a radius, class, of 1 1/2 inches. Now, what you could do with your compass is you could... the pencil back in there. Boy, how am I supposed to use yours as an example? I'm going to have to steal hers again. What you could do is you could hold the compass up to your ruler and measure 1 1/2, like that. It's one way to do it. However, when you measure, it's possible that because of the thickness of the ruler or the protractor, things might get a little off. So what I'm going to suggest is this. Take your ruler on your paper right now and actually draw a line that's 1 1/2 inches. Draw a line on your paper that's 1 1/2 inches. And then use your compass to measure that line. Here's what I mean by measuring the line with your compass. Put the pointy end of the compass on one end. Hold the point still. Slowly open the compass until it looks like it's just the right length. And then make a little arc. Now, if you can see really well, you'll notice I just missed. Do you see that? It wasn't quite perfect. There's a little tiny gap between the end of my 1 1/2 inch line and the circle. That means this isn't quite 1 1/2 inches. So I'm going to have to bring it in just the tiniest little bit and try again. Now I'm right on. So you measure the line that you draw and make sure it's just perfect. It's not a little bit inside. It's not a little bit outside. It's right on the end of your 1 1/2 inch line. Once you have that, you can draw the circle. Now, when you draw the circle, you're going to see me at the chalkboard hold my compass with 2 hands because I've got gravity working against me. We've talked about this. I'm going to hold the point still with one hand. I hold the top of the compass with the other. That's because it's just not feasible to do it another way. What I'm going to want you to do at your seats is I'm going to steal Jalen's compass here. I gave you, oh, sorry. There's your protractor back. I'm a thief. What I want you to watch, you two rows particular, I'm going to shift over here for a second for you guys to see better. Put the point of the compass down. Don't touch the top. Don't touch the pencil. Just hold the point, and then I want you to tilt your compass just a little. And then you can just spin the paper. If you tilt your compass properly, it's very, very smooth. Now, you want to tilt it so you're dragging the paper from behind the pencil. Watch. You two rows particularly, watch. Drag it so it's coming from behind the pencil. If I go in front of the pencil, I'm creating extra friction, and the pencil's going to catch at some point. Drag it from behind the pencil. Do you see the way I'm spinning it and angling it? Okay? You're eventually going to get a chance to practice here, Jalen. Come over here, show you the same thing. So, Griffin, don't hold the top. Hold the point. Hold it by the point. So all the pressure is on the point. You don't want any pressure on the pencil. That's what makes the pencil skip and be jagged. And just turn the paper as you go. Now, the key is having a clear desktop, not having binders in the way or pencil pouches in the way that can keep you from being able to spin the paper. But that'll get you a very nice, smooth, you can practice now, Jalen, very nice, smooth circle. And that's what we want, nice, smooth circle. Once you've got the radius of 1.5 inches, look at number 10. Notice what they want for number 10. They want a circle with a diameter of 1 inch. Well, hold on. A diameter of 1 inch. What does our compass measure, class? It measures radius. That's what this is all about. This is your radius, whatever you measure. How am I supposed to do a diameter of 1 inch, class?
You divide by 2.
Cut it in half. So what is the radius?
Half an inch.
Half an inch. So on your paper, use your ruler to measure a little tiny radius of half an inch. Draw a little radius of half an inch. Then measure that little radius and make your little mark to show that you've got your compass at exactly half an inch. Once you've got it, draw your circle. Other direction, spin it the other direction. There you go. Do you feel the difference? It's not catching anymore because you're coming at it from behind the angled pencil. Are you right-handed or left? I would, if you're right-handed, hold the point of the compass in your right hand. Hold the point of your hold your compass with your right hand. Spin with the left. I'm seeing a lot of right-handed people holding the compass in the left and trying to spin with the right, and it's feeling awkward because you're used to using your right hand. Obviously, if you're left-handed, by all means, left hand the compass. But hold it in your dominant hand. Hold the point, tilt it a little bit, and then allow the paper to spin naturally. Get a nice, smooth circle. We'll do one more together. I like that. Nice touch, Sam. It did need a little something extra. All right, let's take a look at the last one. They want a radius of 4 centimeters. Radius of 4 centimeters. So you're going to have to look at the centimeter side and go and draw a 4 centimeter long line. Do we need to cut that in half, class?
No.
No. Because it's a radius. That's what your compass is designed to use. Only if it says diameter do you cut it in half. Then measure your 4 centimeter line. And draw your circle. All right, we feel good about drawing circles. So the pencil isn't skipping or catching on the paper. The compass isn't slipping or doing anything weird to us. We all feel good about drawing circles? We can draw circles? That's happy. We want to be able to draw circles. That's good. All right. Now, let's go ahead and take a look at the our 1.5 inch circle. Go to your 1.5 inch radius circle. And if you would, use the straight edge of your protractor. You should see the little indent on your paper. Do you see the little hole in the middle from where the compass point was? It's another. Now again, you don't want to jam so hard you like puncture your desk or anything, but you do leave definitely an indent, especially if you're putting the pressure on the point like you should. Draw a line starting on the circle, going through the center, and ending on the circle. In other words, class, draw a diameter. And let's name it Sam. Really, I'm naming the circle, class, A. And there happens to be a diameter, SM. if you would, take that same straight edge and draw, if you would, a radius. And let's call it, who?
Ham.
H-A. Ha! Or we have an angle called ham. Sam has ham. Green eggs. And anyway, all right. Very, very cleverly done there, Ben. I appreciate that. Thank you. All right. Now, this angle, I'm going to put a little 1 right here. Angle 1, is what we call, class, a central angle. Why? Because the vertex is at the center. A central angle is always formed by 2 line segments. SA and HA in this case, class, because the vertex is at the center, the 2 lines that form the central angle will be what kind of lines? Lines can't be acute. They're lines that start at the center and go out to the circle. What do we call a line that starts at the center and goes out to the circle? A radius, right? Radii. So a central angle is always formed by 2 radii. Flip back in your books very quickly, if you would, please, to page 168. Page 168, you see that term there. Central angle, an angle with the center of a circle as its vertex and radii as sides. It's a central angle. 2 radii, vertex at the center. Draw, if you would, another radius, and let's see, I'm not sure if we can keep this Sam-I-am bit up, but let's call this,
S.
we already have an S.
Oh.
T, Tam, Taz, I don't know. And then draw, if you would, 1 more radius, and call this R. AR. So we have AS, AT, AR, AH, and AM, all of these different radii. How many different, class? How many different central angles do we have? 5. 1, 2, 3, 4, 5 different central angles. Now, none of these central angles are vertical to each other because none of them are formed by 2 lines intersecting. But if we were to add angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5, what would be the sum of all central angles?
360 degrees.
360 degrees. You see that there in bold. Put a star next to it on page 165 or 168. The sum of all central angles in a circle is 360 degrees. Now, on your paper, what I'm going to want you to do now is go ahead and extend a couple of your radii. Let's just take ham, okay? Let's take AH and AM. Go and extend those 2 lines. Go and extend AH and AM so that you can get your protractor out now and measure angle ham. Now, all of us will have slightly different angles. Mine is 114 degrees. But go ahead and measure what that central angle ham. Go ahead and also extend, if you would, AT and AR. And let's measure angle rat. I don't know what they're trying to say about you here, Sam, but go and extend the sides of AT and AR and measure angle rat. Or tar.
Rat.
I like rat. And it looks like I'm right at 75 degrees. Now, obviously, if we wanted to measure all of these, we could measure RAM. I guess those sides are already extended anyway. Yeah, okay, fine. We'll measure angle RAM. It's already got extended sides anyway. And it looks like it's right at 44.5 degrees. I'm going to say 45 degrees. We could measure all the angles if we wanted to, but here's what I want to point out next. Do you notice that each angle, class, watch, each central angle with the ends of the radii cuts off an arc? This central angle cuts off an arc. Do you see that? The term for cutting off is the same as what we use in football for cutting off the pass. Right? The quarterback tries to throw to his receiver, and Michael leaps up and he cuts off the pass. We call that an interception. Interception, yeah.
I thought you meant like.
Oh, not a pass break, a PB. I was going for interception there. But the term is intercept, right? When an arc is cut off by an angle, we say that this central angle intercepts an arc. Here's something you need to know. The arc can be measured in degrees also. And an arc, in this case arc RT, is a 75-degree arc. Why? Because its central angle is 75 degrees. Arc RM is a 45-degree arc. Why? Because its central angle, the one that intercepts it, is 45 degrees. So class, what about arc HM? How big do you suppose arc HM is?
114.
114 degrees. Easy math, right? Once you know the size of its central angle, you know the size of its intercepted arc measured in degrees. So an intercepted arc has the same measure as its central angle. Look, if you would, now at page 170. Page 170. Go ahead and put the book back up on your desk now. Move your book back up to your desk. Some of you wish you had longer arms and could reach better. And if you would, on page 170, there's a circle O, a yellow circle. Take just a moment, use the straight edge of your protractor to extend all 5 radii. Take a moment to extend all 5 radii in circle O. Extend all 5 radii in circle O. I want you to measure all 5 central angles that are formed. Yes, sir.
There's only 3.
On page 170.
Oh.
There we go. Extend all 5 radii of circle O there on page 170. Once you've extended the radii, measure those angles and fill in numbers 16 through 20. Remember, when you're reading your protractor, if it looks acute, make sure you choose the angle that's the acute angle on the protractor. If it looks obtuse, pick the one that's obtuse. You're on page 170. Circle O. Oh, you got your book upside down. Okay. It looked like you were on the wrong half of the page. I'm like, what's he doing? Okay. You're good. Now, if you want to check, add up your angles. Once you get all 5, they should add up to what, class? 360. Or they should at least be close to 360, right? I mean, it's hard measuring when it's in the book. I get that. So if you're a few degrees off, if you're like 354 degrees, you're probably close enough. But in a perfect world, they should add up to exactly 360 degrees once you've measured all 5 of them.
you said it'd be like 354.
That's what I got. Okay, that means you're I mean, again, there's 5 angles, so you're only 6 degrees off total, so that's an average of like maybe 1 degree off on each angle. That's not bad at all. Okay, something isn't right. Oh, EOA. What kind of angle is EOA? Ah. If you're 100 degrees off, something's wrong. You know, quite 100. I was exaggerating slightly there, saying pick it on you. Just a little bit longer to work on these. Your arms aren't long enough, are they? Looks like most of us are just about finished with these. Let's see how we did. Even if you didn't get all 5 angles measured, check the ones you did get. For angle AOB, my answer key says it should be 100 degrees. AOB should be 100 degrees. For angle BOC, my answer key says it's a 35 degree angle. 35 degrees. For angle COD, that's going to be a 74 degree angle. 74 degrees. For angle DOE, 18 degrees. 18 degrees. And then angle EOA, the big one, is 133 degrees. How many of you were 3 degrees or less off on every one of your measurements? 3 degrees or less on each one that you did, even if you didn't get them all done. Okay, a couple of you. How many say I was good on all but one? I had one angle that was off by a good bit. All right? Questions on measuring angles in a circle? Questions on that? All right, let's do this if you would. Let's suppose we want a circle. Back to, you can go and put your books next to your desk again, with a diameter of 5 centimeters. Let's suppose we want a circle that has a diameter of 5 centimeters. If we want to draw that circle, what should we do? Luciana?
Draw a line that's 2.5 centimeters.
Good. Draw a line that is 2.5 centimeters long. So, on your ruler, measure off 2.5 centimeters. Measure off a 2.5 centimeter line. Measure that line, and then draw your circle. Once you've drawn the circle, take your pencil and make a little dot right where the indent is on your paper. And we'll name this L for Luciana. We'll name this circle L. We're now going to do problem 21 in your textbook. Problem 21 wants you to construct, or draw rather, 3 central angles on your circle L. The first angle they want is a 100 degree angle. Then they want a 90 degree angle. And finally a 170 degree angle. Question, class, how many angles do I have to draw? 2. But there's 3, Mr. Nadaski. Right. But once you've drawn the first 2, you realize the third one's already going to be there, as long as these add up to 360, right? And they do. So go ahead and take your protractor, and using the straight edge, draw some radius. And let's see here. What shall we name the radius? LZ. All right, we'll name it LZ. Z doesn't get used very often. Use your protractor now to measure a 100 degree angle. Measure a 100 degree angle. let's name this radius L
R.
R. Once we've drawn the 100-degree angle, notice you're going to have to move from where you were. We're going to have to start here now. So line up your protractor, and the next angle we want is a 90-degree angle. Well, that shouldn't be too bad. Go and draw now a 90-degree angle. And let's name this radius L S. I just saw this. This sector of the circle is named loser. LZR. Or this way, looser. Did you do that on purpose? All right, now, that means, class, how big should angle SLZ be?
170.
It should be 170 degrees. Notice it's almost a straight line, right? It's almost a straight angle. And there's our 3 angles. They gave us 3. We only had to draw 2 of them. Let's suppose we want let's say we want a nice big circle this time. We want a 6-inch diameter. A 6-inch diameter circle. Well, class, that means we're going to need to make the radius 3-inch radius. So, on your paper, draw yourself a 3-inch line. Now, you might want a blank side of the piece of paper, because this is going to be a pretty big circle, isn't it? Measure your 3-inch line, and then draw your nice big circle. 6-inch diameter. And let's see. Let's name this circle B. B. We want, number 22, 4 different angles. We want a 90-degree angle, a 50-degree angle, a 125-degree angle, and a 95-degree angle. All right, go ahead and draw yourself a radius. And let's name it BE. And let's make our 90-degree angle. Go big or go home, I always say. Here we go. 90-degree angle. And let's name this radius B.
G.
J.
G.
J.
No.
G.
G. No, J. All right, maybe the next one can be G.
No,
right.
M.
M.
G. Finish off.
Hush, hush, children. All right, next angle we want is a 50-degree angle. Remember, you're going to want to come off of the new line you just drew and measure yourself a 50-degree angle. We'll go ahead and name this one BG. For our 50-degree angle. Next angle, 125. Should it look acute?
No.
Better not. Better be obtuse. And we'll name this one BM. Bam. And 125 degrees. And again, I don't need to draw the last angle. It's almost a right angle, isn't it? Just a tiny bit off of being a right angle. 95-degree angle took care of itself. Now, question for you. Once we've got this all drawn there on your paper, how big is arc EJ? How big is arc EJ? It's a 90-degree arc, because remember, class, an arc is always equal to its intersecting central angle. The central angle is 90, the arc is 90. How about angle or arc GJ, class? How big is arc GJ?
50.
It's a 50-degree arc. How about arc GM?
125.
125 degrees. And that means that 95 degrees is the measure of which arc?
ME.
Me. Me is 95 degrees. That means my temperature is really low, because that me should be 98.6. But anyway, or 97.1, or whatever they've established the new body temperature should be. Questions on drawing central angles, measuring central angles. Again, a central angle, class, has the vertex at the center, and the sides of the angle are always radii. Always radii, which means they are equal in length to each other. It's true. Drop down to number 23. Number 23, what 4 arcs? Now, technically, there's more than 4, but as we look at 23, put your books on your desk again. There are 4 arcs that you see pictured there. We see little arc VT. If you would, next to arc VT on your picture, on arc VT, outside the circle, kind of like here, I could label this as a 50-degree arc. Go ahead and label arc VT as an 88-degree arc. Label arc VT as an 88-degree arc. You see that little tiny guy, VS? That's a 13-degree arc. Arc SU, or US, is 131 degrees. 131 degrees. At your seats, figure out how big UT is. At your seats, figure out how big UT must be without measuring. How do we do it without measuring? Well, how many degrees are there going to have to be all the way around, class?
360.
360. At your seats, figure out TU. Call it when you've got it. 128 degrees. 128 degrees. Okay, so question. How big is angle VXT? How big is angle VXT, class? 88 degrees, because a central angle is always equal to its arc. How about angle SXU? 131 degrees. How about angle VXS? 13 degrees. And angle TXU? 128 degrees. Measure the radius of that circle with your ruler, if you would, please. You can measure any of the radii you want, but go ahead and measure the radius of that circle. Now let's go inches. What is the radius, Jalen? It's exactly an inch. What about the diameter? There isn't a diameter for you to measure, though. So what's the diameter, though, class? 2 inches, because if the radius is 1 inch, obviously the diameter has to be 2 inches. Questions on that? Any questions on what we talked about today with circles, central angles, arcs, that kind of stuff? All right, no homework this evening. We're going to pick up with more circles. We're going to talk about that distance around a circle tomorrow. Didn't quite have time to get to it today. Anyone remember from yesterday what we call the distance around a circle?
Circumference.
Circumference. For a polygon, we call it what? Perimeter. But for a circle, we refer to it as circumference. All right, no homework. When the bell rings, you'll be dismissed. Have a wonderful rest of your day.